Have you ever really stopped to think about the stuff around you? I mean, why is your t-shirt made of cloth, but a window is made of glass? It seems, well, obvious, right? But the why behind it is actually this amazing scientific detective story. So today, let's become detectives. We're going to follow the clues to figure out how we pick the right material for the right job, and you'll see why that skill is so important to, well, being human.
And that brings us to our central mystery for today. It sounds almost silly, doesn't it? But trust me, the answer to this one question, it unlocks a huge secret about how the physical world works. So here it is. Why can't you use a tumbler made of cloth to hold water? Come on, let's put on our detective hats. The investigation starts now.
All right, so our first investigation. Every good detective knows you've got to start with the basics. To crack this tumbler conundrum, we first need to know exactly what we're talking about. And the key word for us is material. It's really just a fancy word for the stuff that things are made of. You know, paper, wood, glass, plastic, you get the idea. But here's the crucial part. We don't just pick this stuff randomly. It's not like you'd build a boat out of paper, right? We choose a material based on its special properties and, most importantly, what we need that object to do.
Okay, so to solve our big puzzle, every good detective needs one thing: clues. And in science, our clues are what we call a material's properties. So let's start gathering our evidence, one clue at a time.
All right, let's get into it. It's time to start investigating these properties and gathering our clues. We've got 4 main ones we need to look at to crack this case. Our first clue is all about appearance, or, if you want to sound scientific, luster. It's basically, is it shiny or is it dull? So lustrous materials, like most metals, iron, copper, gold, they've got that natural shine. And then you've got non-lustrous stuff like paper or wood that's just dull. But here's a cool little detail. Sometimes a piece of metal can look kind of dull on the outside. That's just because the air and moisture have gotten to it. But if you were to cut it open, bam! You see that true, brilliant shine inside.
Okay, clue number 2, hardness. This one's pretty intuitive, right? Hard things, like a stone or a piece of wood, are tough to scratch or squish. And soft things, like an eraser or a sponge, are, well, they're easy to compress. It's all about how well a material can resist being pushed around. Of course, it's all relative. A tire is way softer than iron, but it's a whole lot harder than a sponge.
Clue number 3 is transparency, and it's all about how stuff plays with light. The best way to think about this? Imagine you're playing hide and seek. Hiding behind a clear glass door, that's a transparent material, and you're going to get found instantly. Okay, what about a frosted glass door? That's translucent. They can kind of see your shape, but not clearly. Better, but not great. The winning move? Hide behind a solid wooden door. That's opaque. No light gets through, and you are totally hidden. That's really all there is to it. And for our 4th and final clue, let's talk about solubility in water. This is a super simple experiment you could do right now. Imagine you grab a glass of water. Now you pour in some sugar or salt, give it a stir, and poof, it disappears, right? It dissolves. We call that soluble. Now, what if you tried the same thing with sand or some sawdust? You can stir all day, but it's just going to float around or sink to the bottom. It doesn't disappear. That's insoluble. This simple idea is so important for everything from making a drink to how our own bodies work. All right, detectives, let's solve this thing. We've got our clues, right? We have appearance, hardness, transparency, and solubility. We've gathered the evidence. Now it's time to put it all together and reveal the answer to our mystery. And the solution? It lies in the very nature of matter itself. You know, all of these materials we've looked at, from a school bag to a single drop of water, they all share 2 really fundamental properties. These properties are what all our clues have been pointing towards. Think about it. If a school bag is on a chair, you can't sit on that chair, can you? Why? Well, duh, because the bag is taking up space. That simple, obvious fact is a hint at a universal truth. So, property number 1 is mass. It's a sciencey word, but it just means the amount of stuff that's packed into an object. It's the reason some things are heavy and some things are light. It's what we measure when we use grams or kilograms. And property number 2 is volume.
This is simply the amount of space that stuff takes up. It's why that school bag on the chair prevents you from sitting there. It's why you can't pour more water into a bottle that's already full. The space is already occupied. We measure this in liters and milliliters.
Okay, so here's the grand reveal, the big aha moment. You take those two things together, mass, the amount of stuff, and volume, the space it takes up. Anything that has both mass and volume is, by definition, matter. And that means, well, everything we've been talking about. The wood, the glass, the water, even the air you're breathing right now. It's all matter.
So let's finally solve the case. Back to our original question. Why can't a tumbler be made of cloth? Well, now we have the answer. It's because of its properties. Cloth is porous. It's full of tiny holes. So water, which has volume, will just leak right through. Plus, it's not hard enough to hold its shape against the mass and volume of the water. So for a job like holding water, we need a material with the right properties, something hard, non-porous, and waterproof. You know, like glass or plastic. It all comes down to choosing the right material for the job. And with that, case closed. So we solved the mystery of the cloth tumbler. Awesome. But this whole process of sorting things by their properties, it's not just some nerdy thing we do in science class. It's a deeply human skill. And now let's zoom out and see why this matters so much. Everywhere from your own kitchen all the way back to ancient India. Think about it. We group things all the time. It's this basic human impulse to create order and find patterns. You do it without even thinking about it in your kitchen, right? Spices go here, dolls and pulses go there. A pharmacist does it with medicines, arranging them carefully. We do it to make our lives easier, more efficient. And in science, well, classifying plants, animals, and materials is how we begin to make sense of the entire universe.
And trust me, this is not a new idea. People have been doing this for forever. Just look at this timeline of pottery from the Indian subcontinent. We're talking thousands and thousands of years ago. People were already expert material scientists. They had to figure out which clay had the right properties, how to shape it, how to fire it in a kiln to make it hard and waterproof. They were using the exact same principles we've been talking about to literally build their civilizations.
And just how sophisticated was this ancient knowledge? Get this. This shloka here is from a foundational ancient text on Ayurveda, and in it, it lays out 20 different properties, things like heavy or light, cold or hot, soft or hard, that were used to describe and classify all physical matter. This wasn't just guesswork. This was a deep, systematic way of understanding the material world that existed long, long before modern chemistry labs.
So you see, there's this direct line that you can draw through all of human history, from an ancient artisan choosing the right clay for a pot to a modern scientist in a lab engineering a new kind of polymer. The core idea is exactly the same. Understanding materials is and always has been the engine of human progress.
And that brings us to a final, pretty big thought. We have become absolute masters at understanding, choosing, and even creating materials. Take plastic, for instance. It's a miracle material, really. It has all these incredible properties that have totally changed our world. But here's the question I want to leave you with. Has that invention been an ultimate good, a boon, or has it become a curse, a bane? Something to think about. Thanks so much for joining me on this little detective story.